Welcome, everybody. Our apologies for the late start. In spite of several rehearsals, we're having some technical difficulties today, but we're going to get started now. So today's webinar is Designing Net Zero Energy Buildings, Obstacles and Lessons Learned. Next, our facilitator was going to be Elizabeth Debs, but she is having some trouble logging with her audio today, but she would have done an excellent job. I'm Linda Reeder. I wrote the book Net Zero Energy Case Studies and Lessons Learned, and I'm an associate professor in construction management at Central Connecticut State. The goal of this course is to flatten the learning curve for designers undertaking or hoping to undertake a net zero energy project. Attendees will gain knowledge about processes to engage in and pitfalls to avoid while learning how to approach the challenges peculiar to designing a net zero energy building. AIA Knowledge is a registered provider with the AIA Continuing Education System. The program is registered with the AIA Continuing Education System for continuing professional education, and questions related to specific materials, methods, and services will be addressed at the end of this presentation. So if you have a question, you should see a box with a chat box. You can submit the questions there, and we'll respond to them at near the end of the program. And the presentation is protected by the U.S. and international copyright laws. Reproduction, distribution, display, and use of the presentation without written permission of the speaker is prohibited. So as you heard, I wrote this book, Net Zero Energy Buildings, Case Studies and Lessons Learned. I interviewed more than 80 project team members and did case studies, detailed case studies of 18 buildings that had performed at net zero energy. So first, I'd like to thank all those people, the architects, engineers, owners, and constructors who spoke to me and shared all the lessons that they had learned, as well as a lot of project data, so that I could share those lessons with you here today. One of the great things about being an architect is it's never boring, because there's always something new to learn, but sometimes it can seem daunting to learn something new like net zero energy buildings, how to design those. So that was one of my goals in writing this book and in speaking to you today, was to make it a little easier for people by sharing the things that the people who have gone before us have learned. So today in our program, I'm going to identify some obstacles to designing net zero energy buildings and how to overcome those obstacles, and also give an overview of some common lessons learned. So even though each design team and project team learned different things, there were some, regardless of project type, that were common to a number of projects, and so we're going to talk about some of those here today. And in terms of the definition of net zero energy buildings, it's a low energy building that produces as much or more energy than it uses in a year. So over a period of time of 1 year, the building generates as much energy as it consumes, or more energy than it's consumed. So that's the definition we're working with here today. So this IECC map of climate zones shows, you can see the numbers in the white little pinheads, the projects that I covered. You can see there's quite a range of climates. Also, this is a list of the case study projects that I wrote, and they are in a number of, not only in a number of locations, but also different project types. They basically broke into 4 project types: office, educational and community buildings, retail, and residential. And they ranged in size from about 800 square feet to 360,000 square feet. So there's quite a lot of possibility in terms of designing net zero energy buildings. One thing that many of the project team members told me, no matter what project they were working on, is that it's not the same as designing a conventional building or even as designing a LEED building or their highly efficient building. And we're going to talk in more detail about some of these things, but some of the ways it's not the same is a much higher level of owner engagement required. The design process is different, and the commitment and vigilance on the operations side is much greater. So those are some of the challenges. On the plus side, zero, as in net zero energy, is a tangible goal. So Alec Holzer at Opsis Architecture, which designed this middle school building, said that even middle school students understand what zero is. If you're designing a building that is like 50% more efficient than code or some concept like that, that's really a little challenging for users to understand. Whereas if you say it's net zero, that's a more readily understandable concept to people, so that can help. But still, the design process is different. So one way to look at it is normally when we're working with clients, we need to look at the building program, the budget, and the schedule. But when you're doing a net zero energy building, then the energy performance becomes a fourth element. So every decision needs to be looked at through the net zero impacts. So whereas in a highly efficient building, you might incrementally be adding in features that improve the energy performance. In a net zero energy project, you have to go all in, and then you can remove elements that aren't contributing. So some of those ideas came from Jim Hanford at the Miller Hull Partnership, and they designed the Bullet Center. And the way they helped visualize it is this is a graphic of the PV array on that building, and you can see on the right every energy use has a certain number of panels designated to it, and so that's one way to kind of graphically understand your energy budget. Another way designing a net zero energy building is a little different, is evaluate the costs differently. So instead of just looking at the first cost, you have to look at the cost of the energy conservation measure and if it can offset the cost of an energy producing feature. So as the price of PV changes, if it continues going down, then it may be more cost effective, even though many of us have been educated to say, reduce the loads as much as possible before adding renewable energy. In some cases, it may be more cost effective for certain energy conservation measures to actually add more PV panels instead of doing a costly one. But another thing that can surprise people is it doesn't have to cost more. It can cost more, but it has been done for that some net zero energy buildings have been constructed for the same cost as comparable buildings in the same market. So this information, this cost chart that you see here, is from the National Renewable Energy Laboratory in Golden, Colorado. They're one of their office buildings there, and it was without renewable energy, the cost was comparable to similar Class A office buildings in the area. So one way they did that was by keeping it simple, and keep it simple was a refrain I heard from these project team members. And some ways to do that are to optimize past strategies. You can see in the photo of that NREL building here that each facade, it has a different treatment to maximize, optimize its passive solar heat gain and daylighting and things like that. Also, they're very narrow bars, which optimizes daylight and natural ventilation. Even though there's a great deal of building envelope on this project because of its configuration, the modifications, it was well insulated, airtight, and it reduces the building's total energy use by about 15% as compared to a baseline building. They also, to keep it simple, specified low-tech and off-the-shelf products, and made sure to specify building and control systems, not only that the local contractors could install, but also that the owners could operate. And that's obviously important to do. So in terms of constructability, it's not only what can be installed, but what's easiest to install. So these are some photos from a Habitat for Humanity community in Wisconsin. They built 18 homes over a 4-year period, and they made some modifications to the design as they progressed to make it easier. So you can see on the left picture, they originally had 9-foot high ceilings with a SIPS attic floor above, and they decided to drop the ceiling, and so they didn't have to try to air seal around the sprinkler heads and the recessed lighting. So that not only made it easier for volunteers, but it would make it easier for anybody, and that could help contribute to better performance. On the right side, they had originally had a wall assembly with 12-inch SIPs, and I found that difficult to work with, and so they reduced that to 6-inch structural insulated panels, and then an interior stud wall with cellulose insulation, which just made it a lot easier to put in the electrical and other systems. So sometimes a new or untested technology can look like a solution to meeting a energy goal, and sometimes it is, but sometimes it might not work as expected. So in about 2010, Corgan was designing a middle school, and it was a really large project for that time in terms of net zero energy, and they ended up using a control system which was the manufacturer's largest insulation at the time, and it has continued to cause them problems in terms of getting the control system working well and providing useful data. So in that example, it didn't work so well for them to use this technology, new technology. But on the other hand, they used Solyndra panels for their solar panels. You can see that on the right side of the screen. And they were very happy with that. All of the school, everybody was really happy with that. Unfortunately, there was a hailstorm which knocked out about half the panels, and they had to replace them with a different product because Solyndra was no longer in business by then. So every project team will say energy modeling is essential, and many of you may use energy modeling, but what is especially important in a net zero energy building is that the client understands the underlying assumptions in the model. So in addition to it being a design tool, the energy model has to be, make sure the owner understands that any things that they do, how much impact what they do will have on the energy model and ultimately the building's performance. So things that the owner controls that will have a big impact are the operating schedule. In some cases, the building might be successful. You add another program, you extend the hours, and it may lose its net zero energy performance just because it's being operated longer. So the owner needs to be aware of that. And then looking at what the existing equipment is moving into the new facility, and also any planned equipment purchases that the owner is going to make. The design team really, and the energy modelers really need to understand what that equipment is. And in several cases, something as small as a coffee maker had a really unexpected impact on the energy performance. So it's really looking at things closely. And something the energy modelers would like me to share with you is that it's really important to include time in the design phase to do all this energy modeling. Testing assumptions with energy models was something several design teams shared as something important to do. I think a lot of us have been kind of trained to think that to have a really efficient building, you can have a long, skinny building oriented just so. In this example, you can see a site plan of a existing building in Phoenix that the Smith Group did some modeling at, and they were able to renovate it to be a net zero energy building. So in other cases, Linda, can you mute your speaker? In other cases, an ideal tilt of the PV panels, changing the tilt a little didn't have such a huge impact. So for example, this is one of those homes in the Habitat for Humanity community, and they designed the roof slope to be 9 to 12, and typically Habitat homes have a 5 to 12 roof slope, but to optimize the energy production, they made it 9 to 12, which meant that they used it meant that they had to use subcontractors because they had the steeper roof. Later, as the buildings progressed, because they were doing a few each year, and the cost of solar panels went down, they ended up reducing it back to 5 to 12, making a more shallow roof slope. And then some of the savings from having volunteers build the roofs went to additional PV panels. So as the design of the buildings makes the buildings more efficient, the impact of the users on the buildings become greater. So for example, you can see on the left side that there's office buildings. An average office building has about 16% of its energy goes to office equipment. In contrast, the Bullitt Center, where they've reduced all the loads they can from the building system, the plug loads from the occupant have gone up to about almost 50%. So some owners have taken steps like delamping vending machines, reducing personal equipment, getting rid of chilled drinking water fountains, and instead having kitchenettes with refrigerator ice makers, and more people sharing each of those break rooms, sharing printers among people, things like that. But no matter how much you and the owner reduce the amount of equipment there is, something that you need to remember is that people are going to come in. If there's any public place to charge something, people will use it to charge their devices. They will roll in their electric wheelchairs, they'll plug in their laptops, and they're not intending to sabotage your energy budget. They probably feel good about themselves because they see those solar panels and they're they feel like they're charging with green power maybe, but it's something that you just need to account for when in your design, that if you have publicly available receptacles, so maybe make those, account for them and maybe make them a little more inconvenient receptacles. In terms of looking at things minutely, some other things are, this is a staircase from the Bullitt Center, and you can see it would be an attractive staircase to walk up, not your typical emergency stair. So they have created what they came to call this irresistible stair, and they located the elevator less conveniently, so that can save energy, and maybe it also has a good impact on occupant health as well. Something that many design teams found out, some of them the hard way, was that even if a building is not open at night, it doesn't mean that it's not using energy at night, that things are happening at night that need to be accounted for. So for example, if there's a security person doing a walkthrough every hour and all of the lights come on and stay on for a set amount of time, the lights could be on for a third or a half the night. So you need to account for that in your design. You need to, some of these building owners scheduled cleaning crews for daylight hours. If that's not possible, then you just need to realize that the lights will be on while people are there cleaning. Sometimes, some of the designers mentioned a challenge in getting the information in the product data that they needed. So some of you might remember 15 or 20 years ago when LEED was just gaining traction, it could be challenging to get information on the recycled content or the VOC content of a product. And now that more people are looking more minutely at energy, there can be some challenges there as well. So This is a Walgreens in Evanston that was designed to be net zero energy, and the design team learned as the last piece of glazing was installed that the performance of the as-built system was worse than the design specifications because the framing system was not thoroughly broken. And this was something that their energy consultant said that he found throughout the architectural industry was that manufacturers weren't that familiar with the concept of assembly performance. So getting the right information can be challenging. In another case, an engineer was trying to find information about the standby power for a variable refrigerant system, and the vendor wasn't able to provide the information and just got frustrated at the level of questioning and said, why does energy matter so much if the system is maintaining thermal comfort? So that can be a challenge, let's see. And Westlake Reed Laskowski started a website, that recool.com, which might be a resource for you. They can review products and systems and share their experience with the design community. So if you are working with an owner who it's very important that as soon as the building opens, it begins performing, its first year, it's a net zero energy building, then you might want to include an energy contingency. So just like you have a construction contingency to address unforeseen events during construction, there are always unforeseen events which affect energy consumption. So this is a photo of the Santa Monica Mountain National Recreation Area Visitor Center, which was a renovated stables, and it was designed to produce 5.5% more energy than it was modeled to consume. And another example is the Packard Foundation headquarters, also in California, and that was designed to produce 19% more energy than it was modeled to consume. And so in both these cases, the owners were able to demonstrate that they had achieved net zero energy performance within a year. So one thing that was different about these projects was they were both on campuses, and the local regulations allowed them to contribute any overproduction to other, kind of credit that overproduction to other buildings on the campus. So the owner was still benefiting from producing more energy than they needed potentially. A different approach, if an owner has a tighter budget, might be to plan for future expansion. And Workshop 8 in the Payasano Green Community, a senior public housing project in El Paso, Texas, designed that way. They had, they needed to reduce the first cost, so they designed the building to be very efficient with a HERS score of 10, and they designed in as much PV systems as they could fit, and then they added space to add, they designed where additional arrays could be added later. And the goal was not only to reduce costs, but also to avoid overpaying, oversupplying the panels, whereas they could understand, there could be a shakeout period of a couple years where the owner would understand how occupants used energy, how much energy they could be expected to use, and also during that time they could optimize the building systems. Unfortunately, in this case, there was a lot of changes in leadership during that 2-year period, and expanding the PV system was no longer a priority to the new leadership. So that can be a risk of waiting, is that it might not happen. Net metering regulations and other regulations matter in considerations for cost and logistics. So, for example, we talked about aggregate net metering, those projects that were on a campus. There's also, it will have an impact on the owner at what rate the utility company compensates for energy that's produced. So in some cases, the renewable energy, the utility company will pay for that renewable energy at the same rate they're selling it. And in some cases, they'll buy it at a wholesale rate and charge the owner at a retail rate. So that can have an impact on the financial feasibility for some people. In some areas, there are capacity limits, so limits to how much energy a project is allowed to produce. And in some places, you're not allowed to have community net metering. So on the right, there's a site plan for that Habitat for Humanity community. And you can see maybe on the bottom, the south side of that, they had planned to have a solar farm, but the utility company objected because they considered it a competing utility since it was going to be communally owned. So that organization is working with politicians to try to get that changed, but that's something to be aware of. Just really check out your net metering regulations. And also, always, any projects, you have to be concerned with the authorities having jurisdiction, but if they're unfamiliar with net zero energy, they may be, or renewable energy, there might be more questions to answer. In one case, there was a project that was required to change the electrical switchgear design to include a custom fabricated disconnect switch for the PV array, so the fire department felt it would be a safer option if they had to fight a fire there. On the plus side of these 18 projects that I looked at, there was a range of project delivery methods that were used, design build and design bid build, and even with public bids, people used a kind of a philosophically integrated project delivery, but not contractually. So you can see on this slide that there is a big range, and for whatever one you choose, the important thing is to maintain a high degree of collaboration. Obviously, a high degree of collaboration would be useful on any project, but including the constructor early is especially important on a net zero energy project. So most of the projects had a constructor involved early in the design process, and those that didn't kind of wish that they had or had used the same one throughout the process. The cost estimating, we talked about the trade-offs between energy conservation measures and adding more generating power, and also for constructability reviews. So it's also good to note that it can be possible to renovate buildings to be net zero energy. You can see 3 projects from 3 different decades here that were all renovated to be net zero energy. It's not, it doesn't mean that every project, there will be challenges, especially for some that are historic, on the historic register. But it's certainly worth taking a look at to see if it's a possibility, because you might be surprised. Another thing that many project team members mentioned to me was that projects need champions. Net zero energy projects need champions, and ideally that champion would be the owner. Like at the Bullitt Center, the Bullitt Foundation has an educational mission, and the owner was very committed to net zero energy. They also net zero water. They were a living building challenge building. So that was really driven by the owner. The owner kept them to task, and that was cited by the design team as being very helpful in the process. In other cases, architects might make the decision to be to kind of be that champion. So one example is the Berkeley West Branch Library, where the city of Berkeley was planning in a few years to require its buildings to be net zero energy, and this architecture firm, Harley Ellis Devereux, said, well, they went for the interview after having done some studies and said, we think we can make this building net zero energy now. And so they were awarded the project. The owner was very supportive of it, but because the idea for net zero energy had come from the design team, sometimes the librarians were a little suspicious of motives. For example, once the building was well underway, the librarians felt like there wasn't enough light in the building. And of course, having a workable library that is comfortable for their patrons was the most important thing for the librarians. The design team had their lighting consultant go in, walk around with a light meter and say that the lighting was fine, but because there was some suspicion from the librarians that they weren't just trying to maintain or attain net zero energy performance. Luckily, this story had a happy ending, and the librarians got more light, and the library was still able to achieve net zero energy performance. But it's just something to be aware of if you decide to be the one that's kind of more pushing net zero energy performance. Another thing about being a champion is that you need to be aware that the role of champion doesn't end when construction ends. As one owner told me that a net zero energy building is like a 3-year-old. You have to watch it all the time. And on that note, it's essential to have a measurement and verification plan. And in order to have that be successful, you need to help make sure that the owner budgets for that measurement and verification once the building is operating. You need to have really thorough specifications about what commissioning should entail and include commissioning the controls and the metering systems. And, think about it as continuous commissioning, the measurement and verification. One thing that several teams mentioned, and they had learned this the hard way, was that to make sure that you include a meter to measure PV production. So it might be tempting to just figure that the utility company is going to take care of that because the energy that's produced will be fed into the grid and extra energy, and everything will be tracked by the utility company. But that is not always the case, and in several cases, the PV system went out and people were not aware of that until a month or more had passed. So maybe a lightning strike or vandalism or some other reason, some of these projects were trying to achieve a year of net zero energy performance and they lost their raise. That was a problem. It's not great, it's not ideal to have your building not operating the way it's designed in any case. So be sure to include a meter and to measure production, and also an alarm to let somebody know if it goes offline. So it can take a year or longer to really finesse and fine-tune the building controls and the building systems to optimize the operation of the building. And you need to make the owner aware of that. Sometimes the owners will make ask the design teams, engineers, or energy consultants to stay on for a period of time. In the case of this is the back of the Aspinall Federal Courthouse. They asked the design team's engineers to stay on board for 18 months and help them optimize the building controls, but also the DLR group said that part of their mission was what they called behavioral commissioning. So in addition to looking at the building systems and controls, they also educated occupants about the impact of their activities on the building's energy consumption. And over the course of the time, they did achieve a great reduction in energy consumption through this fine-tuning and behavioral commissioning. In a few cases, the owner was able to hire a full-time building operator to help maintain and optimize and maintain the building's performance. And so we've talked about that the occupant has a big impact on the building performance, and sometimes the building has a big impact on the occupant and they need to make some adjustments. So in an office situation, you see here a photo from the inside of that National Renewable Energy Lab office. Users have to adjust to some things, like maybe radiant and heating and cooling is used. That's going to be a lot quieter than forced air, and they're not going to feel the air movement. So even if the temperature is the same, they might miss that air movement. And the quietness can result in some, sound issues. So there can be sound masking machines. You can have rooms with ceilings that are designated for conversations and phone calls. Some people in this building said they just had to get used to the idea that they couldn't greet everybody who walked by their desk. So things like that. They also, for the movement of air, gave people personal fans that plug into the USB ports so that if they wandered away and their computer hibernated or went to sleep, then the fans would turn off and not be using too much energy then also. So in this residential project, this is that Paisano Green community pictured here. It's a public housing project in El Paso. Some of the residents found that the programmable thermostats that would really help achieve some of the energy savings were too hard to program. They're too complex for them. And some residents were unfamiliar with air conditioning systems. Either they hadn't had a cooling system and left the windows open all the time, or they had evaporative air cooling. The air's really dry there, so they had evaporative air cooling systems, and you do leave the window open there. So they had to do a lot of training with the residents, kind of educate them and help them understand how to use the air conditioning system most efficiently and effectively. And also the staff went around and helped residents program thermostats.
Yeah, I see. And
so it can be tricky to predict residential consumption. If you're dealing with a school or an office building, somebody in that hierarchy can tell people, the other occupants, how to behave in that building, and kind of there's some controls over the occupants' behavior in those use groups. But in a residential project, people are going to live how they want to live. It's their house. So that can be a little trickier to guess, to accurately model for. You can see in this table here, for units of the same size, there is a range in consumption. So this project that you see pictured here is a 10 townhome community near Seattle. And weather is also a factor in any project. So over a 2-year period, this complex performed at net zero energy. But for one of those years, it didn't qualify as being net zero energy. So it's that variations in weather is another one of the unknowns sort of that can derail your efforts at net zero energy, but hopefully only for that one year at a time. So net zero energy can add cost. We've talked about how it doesn't have to add cost, but it certainly can add cost. So this was a project by the Lend-Lease, which develops and operates military housing. This was in Midway Park in Camp Lejeune, North Carolina. And they developed a community of 537 LEED Silver homes, and they decided to see what the cost would be to improve one of these to be a net zero energy home. So they had a grant to get the renewable energy, but then for the consultant fees and for the improvements to the building systems and insulation and so on, they found that was an additional cost of $20,000. So for them, it was not worthwhile, even though they were operating the buildings. For a couple reasons, it wasn't considered financially feasible for them to make that change on a greater scale beyond this one test case. One of those reasons is because the cost of energy was so inexpensive. Electricity was really inexpensive in North Carolina when they were doing this. And also at that time in North Carolina, the regulations didn't allow for power purchase agreements for renewable energy. So what a power purchase agreement is, it's when a third party owns, installs, and maintains the renewable energy system, for the owner, and then sells back the energy at kind of a fixed rate, or it's usually a rate that's lower than the utility company. So that's a way that that the developer owner doesn't assume the first costs but can still have these renewable energy on their homes or buildings. And so this was a problem for them because it just wasn't financially feasible. But it does give you a sense of what the cost was for them. Even though they didn't go on and continue to adapt their homes to be all net zero energy, they found the exercise of doing one to be really useful in terms of just drawing their subcontractors' attention to certain good practices in terms of air sealing and insulation and not compacting fiberglass insulation and that kind of thing. In the St. Croix Valley Habitat for Humanity, that 18-home community, the typical home, conventional homes that habitat had constructed were in the $100 to $120 per square foot range, and habitats are always concerned about having low operating costs for their homeowners, but then in this community of net zero homes, the per square foot cost range from $110 to $200 per square foot. So the low end of that range is right within the range of their typical home, and you might wonder why there's such a big range. One reason was as prices change for things, they change their designs. So we talked about changing the roof slope and adding more PV. We talked about, they also eliminated, they used to have when they first started building these homes, they had a solar thermal system, and they eliminated that and increased the size of the PV arrays as the cost of PV panels went down. And that saved about $9,000 per home. And they just learned things as they went along that resulted in some energy savings. Net zero energy can add value. So this green community in El Paso, it costs per unit about twice the cost of a typical affordable unit in that market. So that is a lot of additional cost. But at the same time, the life cycle analysis by the design team calculated that the per unit life cycle cost was actually 20% lower than a typical unit in that market. And that was looking at energy and water savings as well as durability. At the Z Homes project, those townhomes near Seattle, they sold for about 25 to 30% above market rate, which was good for the developers. But the homeowners also benefit from the savings, which is estimated about $3,000 to $4,000 a year versus a conventional home on lower costs of utilities. And there were also tax credits available at that time to those homeowners. Some project teams asked me a question, which I'll pass on to you because it's an interesting question, which is why are energy saving features required to save money when so many other features we design are not evaluated on this basis? So we do a lot of things in our designs that have a cost that aren't expected to have a payback, but always energy saving features are. So it can be challenging, especially challenging in a residential project to have to achieve net zero energy. We talked about how people want to behave, how they want to behave in their homes. Even if the people in the homes are educated about what the impact of their behavior is, just understanding it might not make them want to change their behavior because it's their home. Another challenge in residential construction can be that it's hard to sell home buyers on things they can't see. So if they walk into a home and they see a granite countertop, they can be like, yes, I want that. But they don't see the insulation, so it doesn't have that same reaction. So one thing some people suggested was having a mock-up of a wall so that owners can see the insulation in one home compared to a typical home. And also if you can do some quantify the savings of utilities that having those different wall assemblies might result in. And then another challenge is that the sun is out during the day and people are at work during the day, so that residents mostly use more energy at night, and PV arrays generate more energy during the day. So I think that as battery storage becomes more more feasible, more available for a reasonable price, that this problem might take care of itself over time. This is a picture from the Honda house on the UC Davis campus, where they have installed a 10 kilowatt battery energy storage system that uses the same lithium ion cells as their electric fit here. And it stores energy produced during the day for homeowners to use at night when they're home. So that is a potential in the future to have battery storage. So that was just a quick overview and of some of the lessons learned and challenges and some ways to overcome them. And now I would like to see if anybody has any questions.
Linda, can you hear me?
Yes.
Okay. I'm going to go ahead and present some of the questions that were asked this morning. We have very little time, but let's go ahead and try to address a few of them. Are architects doing their own energy modeling, or are they using consultants? If they're doing their own, what programs do you recommend?
Okay, so I think that for some of these, it depends on the project and the level of complexity. So at a smaller scale, like the net zero energy buildings, the project manager for Habitat for Humanity did their own energy modeling. So for the single family homes, I think some architects do their own modeling sometimes. As projects get more complex, they tended to use energy consultants, and there's a huge range of programs that they use. And for the different projects that I looked at, I did include which programs were used for energy modeling on each of the projects, but I'm not prepared to make a blanket recommendation.
Okay. Another question is, if costs are comparable on conventional and net zero buildings, why aren't more owners choosing to do this?
Well, one reason is they are not always comparable, and another reason is the perception. So I teach students, college students, and I go in the classroom and I say, what do you think the extra cost of doing a LEED building is? Not even net zero energy, but just generally a green building, a sustainable building. And they say anywhere from like 20% to 80%. So, some owners are more educated and have more experience with building than my first year college students do. But I think there's a perception that it is a lot more expensive. And it certainly can be a lot more expensive depending on what strategies you use to address it. There's also, I think we have to learn more. The design teams are trying something new, and there is a learning curve for us as well. So that can be daunting sometimes.
Okay. One of the questions I've had is several times is, will the slide deck be available to be shared? The slide presentation.
Yeah, I think it will be.
Okay. I mean, we can share it if you're willing to share it.
Yeah,
okay.
I'm just going to check. The reason I'm hesitating is because people gave me permission to use their photographs, and I asked for using them for the webinar and for posting the webinar online, but I didn't ask about distributing them. I just don't want to. I need to check my agreements with the photographers before I agree to that.
Okay, so I think the answer to that is if you're allowing them to be posted to the webinar online, then it will be available for people to look at.
Right.
Okay. One more quick question. How do the buildings perform as they age?
That is something that, well, it depends on the building, and it depends on how the buildings are maintained and how closely their systems are monitored and verified. So I guess the answer is it depends. Also, sometimes the buildings are a victim of their own success. Like if they are, like there was a school that was net zero energy, and it was a very popular building, and so they ended up adding an after school program at that school location, and so the building was operating 25 hours a week longer, and then it was no longer able to achieve net zero energy. It's because, so it depends. The ones that have people monitoring it all the time, keep going well. One thing I forgot to mention when I was talking about how you should have a meter attached to the PV array, and that somebody should be monitoring that. In addition to the chance that it might go offline, you can also see that the production can deteriorate. Pollen and in dry areas, dust need to be washed off periodically to really keep those operating as best they can and generating as much energy as possible.
Okay, I think that's all we're going to have time for as far as questions are concerned right now. Everyone will get a survey report sent to them. They can go online and complete that, and that is how you will get your AIA credits when you fill out that survey. The slide on my screen right now shows some further information about that. And I believe that's all we're going to have time for today. Linda, thank you so much for your presentation. We appreciate that.
Thank you.